Now we're going to begin Lesson 5C, the quadratic equation and the discriminant. What you see in the blue box here is the formula for the quadratic equation, with the understanding that you have already put the quadratic equation in standard form, which means ax squared plus bx plus c. This is a really important step because the values that you plug in for a, b, and c into the equation come from the a value being the number attached to the x squared term, the b value being the number attached to the x term, and the c value being the constant. The discriminant is the part of the quadratic formula that falls under the radical, so it's b squared minus 4ac. And the discriminant is what tells you the nature of the roots, or the type of answer that you're going to get from a quadratic equation. Whenever your quadratic equation is greater than 0, meaning positive, it means that the graph is actually going to hit the x-axis two different places. Now this could be a u, or it could also be an n, but it means you'll have two real roots. There are two actual places where you cross the x-axis. If your discriminant is less than 0, meaning negative, it means there's not going to cross the x-axis at all. It could be either up here, or it's possible that it would be down here facing down. But at no point is your graph going to cross the x-axis, which means your two answers would be imaginary roots. They're part of the complex or imaginary system. And then if your discriminant works out to be 0, then that just means it will hit at the vertex, meaning it's only going to have one solution and bounce off from the vertex. So the discriminant tells you whether you should have two real solutions, two imaginary or no real solutions, or one real solution. So if you look at the example we have right here, this is already in standard form. You have your ax squared plus bx plus c. Your a value, the value attached to the x squared, is 2. Your b value, the value attached to the x, is 4. And then your c value, that constant, is negative 4. So you take those three values, you plug them into the discriminant formula, which says b squared minus 4 times the a value times your c value. Okay, you may want a calculator just to help you with some of the arithmetic here. B squared, or 4 squared, is going to give you the 16. Negative 4 times 2 times negative 4 is going to give you a positive 32. So that means our discriminant has the value of 48. 48 is a positive number, so it's greater than 0. So this tells us that this quadratic equation is going to have two real solutions, or roots. Okay? Alright, let's look at another one. Same slide, different example. Here your a value is 7. Your b value is negative 2. Now I didn't take the time to solve this one, so I could be tricky. If I put a negative 3 here, I'd be wrong. You want to make sure that this is in standard form before you get going, because it'll keep you from making a careless mistake. You want it to be set equal to 0, so we're going to take that negative 3 and add it over. Set it equal to 0. Our c value is positive 3, which could dramatically affect your answer. So we plug in our a, b, and c into the formula. B squared minus 4 times a times c. Negative 2 squared is 4. Make sure when you put the b in there that you put it in parentheses. We've talked about that before. And then minus 84. This is going to give us a discriminant of negative 80. So being that our discriminant is negative, or less than 0, then that tells us that our quadratic equation are going to have two imaginary roots. Okay. So if you look at our third example, it's in standard form. Your a value would be 1. your b value is -6, and your c value is 9. You take those values, you plug them in, you have -6 squared minus 4 times 1 times 9. -6 squared leaves you with a positive 36, minus 4 times 1 times 9 gives you a 36. So this is in a case where your discriminant is 0, which means you're going to have one real root. The discriminant kind of helps you, give you a heads up on what your answer is going to be before you have to work out the entire problem. So that's how we use the discriminant, is to tell you what kind of roots you're going to have to the problem. Now the quadratic equation can actually give you your solutions to the quadratic equation. The formula gives you the answers to your equation. The nice thing about the quadratic formula is it works for every kind of problem. You don't have to worry about whether or not it can factor, and there's a typo right there. You don't have to worry about whether or not you can take the square root of it, or you know how to complete the square, or anything like that. No matter what, it's going to give you the correct answer. So it's a good thing to always have in your back pocket. Alright, so here, is this in standard form? Yes, it is. ax squared plus bx plus c, or at squared plus bt plus c. So you identify your a, your b, and your c. Take those values and plug them in. So it's going to be a negative, and then your b value, which is 8, plus or minus. And that plus or minus is important because that's what's going to give you the two solutions. And then we have 8 squared minus 4 times 1 times 19. And we're going to put all of that over the 2 times 1. Okay? Keep in mind your discriminant is this value right here that's under the radical. So we have -8. We have plus or minus. Our discriminant is the 8 squared, which gives you 64, minus 4 times 1 times 19. So that's going to leave us with a -12. So we know that we're going to have two imaginary answers to this. So we're going to combine this step with the lesson we did yesterday on imaginary roots. We're taking the square root of a negative number. Are there any perfect squares in 12? Yes, we're going to pull out the square root of 4, which is 2. We're going to pull out the square root of -1, which is I. That's going to leave us with 3 more under the radical. And then 2. Now can 2 go into the 8 and to 2? Yes, it can. So we're going to go ahead and simplify this to -4 plus or minus 1i square root of 3. And that's two answers. That's -4 plus the square root of 3i and -4 minus I square root of 3. Alright, let's look at another example. Here, again, we're in standard form. We have our a value being 8, our b value being -8, and our c value being 2. So remember, your formula is negative whatever b is. If b is already negative, two negatives make a positive. So if you want to be extra careful, you can show all your work there. Do plus or minus -8 squared minus 4. Your a value is +8, and your c value is 2. And all of that is under a radical, all over 2 times +8. So -8 gives you a +8, plus or minus. -8 squared is 64. 4 times 8 times 2 is actually also 64. over 2 times 8 is 16. And 64 minus 64 is 0. So all of this is going to go away. So we lose the concept of the plus or minus, which is why when your discriminant is 0, you're not going to have two solutions because the plus or minus part goes away, and we're just left with 8 over 16, which is equivalent to 1/2. And so this guy only has one answer, and we would say that it's a double root. Alright, last example. This is not in standard form, so you want to first make sure you put it in standard form. 3r squared minus 8r minus 9 equals 0. So our a value is the 3, b value is negative 8, c value is negative 9. So we have negative b, so it's a negative 8, plus or minus the square root of b squared, so negative 8 squared is 64, minus 4 times 3 times negative 9, so a minus and negative is going to give us a plus 108 here, over 2 times a is 6. So that's 8 plus or minus 64, and 108 gives us 172. So we want to clean up that radical. So what's the largest perfect square that goes into 172? We're going to check on the calculator for a second. So I'm coming up with 4. So if you pull a square root of 4 out, that's going to give you a 2 here. That's going to leave us with the square root of 43 inside. And we can simplify this because there is a common factor between 2, 6, and 8. That is 2. So that's going to leave us with 4 plus or minus the square root of square root of 43 all over 3. And that would be our final answer because nothing else can simplify. And again, realize that that's two answers. That's 1, 4 plus the square root of 43 over 3. And then a second answer, 4 minus the square root of 43 all over 3.